Afternoon to all. Now, with no more delays, we go to initiate the session 3 of our symposium. Okay, we have 4 communications, and follow that we have little period of questions and answers, a discussion. First one, we have the communication named the effect of partial urban elements on finding direction in urban space, exempling of Kadıköy, Yeldegirmeni, by Buse ERKAN, Mehmet Emin Salgan Siuglu. Please. Yes, please.
Is it okay? And can you hear me? Okay. Hello, I am Buse. I am a master degree student in Istanbul Technical University from Turkey, and my advisor is Mehmet Emin Şalgamcıoğlu. And today I will talk about my master degree thesis. Now we are working on it now. It's not finished yet. Title is The Effect of Potential Urban Elements on Finding Direction in Urban Space, exempling of Kadıköy Yeldegirmeni. Kadıköy is the part of the Istanbul, and Yeldegirmeni is the Kadıköy neighborhood. Firstly, the content is abstract background, aim of the research. Secondly, general information and definition. And after case study Kadıköy Yeldegirmeni, after that conclusion and suggestions. Firstly, this is a space of experience, I guess, and perception. The visual perception is the best experience in the city. And then aim of the research. The aim of the study is to base on the combination of navigation tools available in today's technology with the cognitive mapping. It's aimed to create potential routes. They may emerge by examining the potentials of urban elements that people identify in the concept of wayfinding created in their own minds while experiencing in the urban space. Information of Kadıköy Yeldegirmeni. Kadıköy consists of 21 neighborhoods, each with own unique spatial structures and characteristics. The areas that interact with the sea are particularly favored due to sine waves and climate advantages they offer. Hosting visitors from all corners of Istanbul, Kadıköy provides rich structural functions that facilitate interaction between neighborhoods. It's home to educational institutions, commercial areas, and socio-cultural event spaces, as well as health services, making it a significant hub in the Istanbul. And the Yeldegirmeni neighborhood is the first settlement, apartment settlement of Kadıköy, and the historical area. Because of the Haydarpaşa station is a train station and so historical area. Looking at the physical environment, the settlement was built with courtyards. When we entered the apartment or buildings, we look at the courtyards and the social area spaces. And some examples, photos and Yeldegirmeni, the artworks, and the second photos of Italian apartments and historical buildings. When we walking the streets, we see the sea and environmental perception. Gestalt and 5 categories: shape, ground, proximity, similarity, completion, and continuity. The environmental perception contains the Gestalt theory and the Gibson visual perception. I skip. And the factors affecting environmental behaviors are formed as a result of environmental perception and cognition. Environmental behaviors show different effects in different social structures and geographies. In addition to being affected by the structure of social society, urban space is also affected by the structure of social society. Social structure plays a role in social behavior within the city. Regardless of time, environmental behavior is being studied between people and place and space. In other words, there is constantly changing and developing interaction between the concept of human and space. And different categories of the environmental perception, you'll see, and cognitive mapping. The cognitive mapping is also a psychological experience in Edward Tolman, and we are working on the architecture and urbanism. Now I worked my friends and a survey in the Kadıköy Yeldegirmeni in cognitive mapping. When my friends starts a route and they draw again cognitive mapping is on its own perception map. Is also meanings and mental representation, I guess, and genetic algorithm. Evaluationary computation playing an important role not only the software developers but also for designers. There are different types of these in digital-based design, and it can be said as genetic algorithm, which is one of the evaluationary calculations. Genetic algorithm was developed by John Holland in the 60s. Based on natural selection, it's aimed to determine the individual choices and biodiversity of the population in a computer environment in Grasshopper and Galapagos plugin. Thirdly, case study Kadıköy Yeldegirmeni. Yeldegirmeni is the neighborhood asset. And the important notes for Yeldegirmeni. It's a 5 notes. And you see the first notes of the Altı Yol and Boğa. This is a historical street and landmark. It's existed within its distinctive urban furniture, building facade, and paint differences. Both the cultural texture felt in the buildings, and today's buildings continue to exist in this region. Sorry. And the second one is the Halta Street. Important role for the Yeldegirmeni neighborhood. It can be interpreted that there is a strong combination between the nature and the built environment and urban furniture. And the Marmaray. Marmaray is the train line for the Istanbul. And the surrounds the graffiti artwork. And Marmara has a stop in the Yeldegirmeni neighborhood. This stop plays an important role in the transportation to the neighborhood. The visibility of various urban images draws attention while leaving the Marmara and walking along the rail line to the rich neighborhood. And then I think the final note of the bus station. The area referred to Kadıköy's main bus platform is located in the western part of the neighborhood on the seashore. In this region, which is the first and last stop of public transportation from all over the Istanbul, see the same time, the historic Haydarpaşa train station is here, which makes the neighborhood is a historical and urban protected area. Okay, and sorry, the Kemal Atatürk High School is also Yeldegirmeni. Is a historical building, and it is a historical school that still provides education today. There are religious and educational buildings with such a history in the neighborhood. But the reason why this high school is taken as a nodal point is that it's the point where there's still activity in daily life. And I think, I guess the high school is in front of the Democracy Park with old events. After that, I take the syntax 2D and the 5 notes and the visibility frequency you see. And the grasshopper method, I said that the genetic algorithm with Galapagos. I prepared and sorry. After selected curves for the cognitive mapping, my friends, created frames are combined with the move command on them. This is because it forms the basis for future operation of the system. You see, the right pictures for the frequency of movement for draw my curves. After you see the, I want to see my videos, but maybe doesn't work because of format slide share and Science work. Sorry. And in this study, in summary, urban space exists together with city users, and the cognitive mapping and integrated with today's technologies architecture program. I think the new and own mapping and navigators make also. And that's not, sorry. Okay. Okay. Thank you.
Now the second presentation. Formalization and education in architectural and urban design, their hermeneutic dimensions. Carmen Escoda, JOSEP MUNTAñOLA, MAGDA SAURA, Margaret Krawecka, Regina Garcia.
Margaret.
Okay. As part of the, can you hear me? As part of the conversation on the relationship between new design tools in architecture and the brain, our position focuses on the importance of both verbal and nonverbal communication in brain-machine interaction with regards to architecture education. We will draw on Hermetic philosophy and dialogical theory and the link between interlocation, referring to movement through real space and time, or nonverbal communication, and interlocution, referring to speech or verbal communication in terms of placemaking. I will begin by introducing the theoretical framework, followed by a few examples of studies, as well as architecture and urban design projects analyzed through this framework. First, some philosophical underpinnings of architectonic wisdom. Wisdom, for Aristotle, is a bridge between practice and theory. It is a philosophical practice, thus, architectural design is ethical. For Aristotle, the preferential choice does not accept excuses, constraints, nor ignorance in the subject's actions. Thus, pre-deliberate desire, means, and the reflective intention, the end, are the same, ethics. And thus, wishes or desires are virtuous and thoughts are true. According to this phenomenological structure of space and time, architects build a specific human articulation of space and time, which Paul Ricoeur calls the third human space and time phenomenological dimension, and which we call interlocative, in order to distinguish it from interlocutive, verbal communication. It is the third space and time because the first is the cosmic and the second is historical space and time. For Ricoeur, this third architectural space and time is equivalent to the calendar space and time correlation used by writers in verbal written communication. The metaphorical use of physical space in verbal communication is, in architecture, replaced by the metaphorical dimension of time by architects and urban designers. Real day-to-day life interrelates both processes, delimiting real and fictional histories in our brains, as neurologists are now analyzing. We propose that artificial intelligence also falls in the middle zone. According to Paul Ricoeur's hermeneutic theory, meaning in phenomenological and spatial experience is formed through circular movement through the three nodes of a triangular structure. The first node is prefiguration, which refers to the narrative itself or the project design. The second is configuration, referring to the text or the build project construction. And the third is refiguration, referring to the reading of the text or the user experience of a built project. Meaning is formed by cycling through all three nodes several times. This diagrammatic mapping also demonstrates the link between interlocution and interlocation. Further developing this triangulation of project design, construction, and use, we also add the relationship between territory representation and culture, as well as between the brain, the mind, and learning. In this study by JOSEP MUNTAñOLA on how children construct models of cities, it was observed that two main types of cities, or space and time cognitive structures, were formed, the monologic and the dialogic city. The monologic city was formed without any social interaction between the children, while the dialogic city involved verbal discussion among them. After the models were completed, both groups were asked to explain their city design. The children from the monologic city were unable to answer, while the dialogic city children were able to clearly explain the reasoning of their design decisions, making references and connections to real-life social scenarios. Based on the results of this study, it is clear that in the dialogic city model, the final form has a socio-physical origin, with verbal social interaction between the children architects playing a key role in its formation. The form emerges from a dialogical and intersubjective point of view, where physical space and time and social space and time are interrelated, and the different points of view and voices of the children in the Bakhtinian sense are also interrelated. Conversely, in the monologic city, points of view and voices are independent of each other, while physical and social space and time are only interrelated on the individual level. In the dialogic example, the formalization of the third architectural space and time is carried out by children according to its hermeneutic dimensions. Thus, by observing how children organize space, we can better understand how they learn architecture in terms of cognitive architectural development, which can be analyzed in tandem with the simulation of linguistic and verbal communication processes. Since AI is now used in schools, this cognitive architectural development is a fundamental step needed to help future designers and architects to have the knowledge needed to overcome the environmental challenges of today. We would like next to comment on the connection between architecture, placemaking, and abstract art. Abstract art can be viewed as an experimental way of bridging between different spacetimes. Station is neither a copy of the old, nor is it starting from scratch. While machines can do things that the brain cannot, art can help facilitate the dialogue between brains and machines. The artistic power of architecture includes its social use, since we live inside it. An example of this type of complex formalization between brains and machines, using the role of placemaking activities as a bridge between the two, is the lower level of the Columba Museum by Peter Zumthor in Köln. In this building, Zumthor organized the whole as a historical narrative of the city, moving upwards from the Roman and Gothic origins of the city to modernity on the top terrace, looking towards the actual city of Köln. This is an example of formalization of narrativity in architecture as defined by Paul Ricoeur. On the lower level, Zumthor designed an itinerary through the ruins in order to best show the history of the city as documented by the remaining fragments of the museum destroyed in World War II. Thus, the proposal was to create a new place that remembers the old, but without copying it, mixing the three traces defined by Ricoeur in a renewed way. The historical itinerary, present in the physical, mental, and historical path designed by Zumthor, can be compared against algorithmic space syntax analysis to determine whether or not the path can be improved through the interaction between user experience and artificial intelligence tools. A digital representation can be used simultaneously, or a video recording of the behavior of the users can be used in the analysis of the articulation of the physical, social, and mental dimensions of the behavior of each real user in relation to their historical affectations, sensorial and aesthetic qualities of the building, and cultural values by education. Abstract art is not an empty form, but a chronotopic bridge between ontogenesis and the history of cultures. Only people can imagine empty forms. They are produced in between death and life in a social dialogy between absence and presence. Empty forms are not neutral, but open to be interpreted by the readers or the users in an interlocuted or interlocated way. Intuition and conscious mental dimensions share the same void forms as geometry and artistic dialogue in the abstract arts. Virtual environments can be analyzed both by art and science, but a distance is needed between them. This building floor plan by Catalan architect Carlos Ferrater results from knowledge of the evolution of Catalan culture, building on the work and teachings of previous generations of Catalan architects. This painting by Pablo Picasso uses abstraction to capture the experience of a Catalan village. It is experimental in that it combines traditional imagery with avant-garde influences in a new way. Architectural design as chronotopic digital formalization of human dialogic interaction. It is fundamental to analyze the order between prefiguration, configuration, and refiguration in order to understand the interplay between virtuality and reality, the relationships between prefiguration designs and refiguration history in the building or city, and the interplay between interlocation and interlocution within the different dimensions of places, physical, social, and mental. This urban proposal by architect Enric Miralles in the Elborn district of Barcelona is an example of intersubjective generation of knowledge. The users were the actual users who chose their preferred housing form from amongst Miralles models that presented different solutions for the same place. Here, the points of view are actual visual perspectives, which allowed the users to see various significant buildings nearby, such as churches or monuments, which they could choose from. Thus, each building was to be constructed dialogically with other existing buildings in an innovative way. As seen in this plan of the same project, points of view drive the emergence of architectural and urban formalization, the whole project an abstraction of interactions between voices, that is the users, and points of view, that is actions. Like the dialogic children's models of cities shown previously, architectural forms were to be constructed as places that intersect points of view with different voices. Of course, this early 1990s proposal predates today's movement towards users co-authoring computer-programmed architecture. This qualitative study of mine examined performances by ethnic minority communities in Barcelona, focusing on the phenomenon of regularly occurring dance sessions by resident groups of Filipino and other cultures in peripheral, semi-public outdoor spaces. The groups gather in these spaces to play music and practice choreographed dances, often in front of reflective surfaces, while passersby witness these sessions, thereby setting up a performer-spectator relationship. Although the choice of the dance sites might appear arbitrary, they are in fact carefully considered by the users in terms of their physical and social qualities and affordances. The aim of the study was to gain a sense of the factors that determine the best places for dance within the urban context, in order to better understand why certain spaces lend themselves to specific actions and ritual events, how peripheral urban spaces can support self-organizing performative actions and creative cultural expression, and how architecture and urban form can perform cultural diversity in the city. The outcome in the last instance is a reinterpretation of the history of old cities from an innovative dialogical perspective, which can help build a new sense of place for co-living. According to the study that included dancer interviews, the best conditions for places for dance follows criteria. One of these is the place quality of being simultaneously public and private, providing both security and public freedom at the same time, thereby supporting positive social interaction through a successful combination of the two. Another is the theatrical quality of the site, with mirrors or large open spaces. Places were also evaluated based on the type of people that passed through them as potential viewers of the performances. Therefore, it was observed that it is not the physical conditions of the sites themselves that matter, but the specific link between people and place. Consequently, physical conditions only matter if they support and reinforce these links. Therefore, this study on the link between dance and place placeness in urban spaces revealed that the interaction between people and place is the fundamental factor in selecting the best sites for dance in the city. By better understanding the physical and social factors of the best places for dance, urban planners and architects can learn from them towards designing for places of coexistence that can perform free creative expression and cultural diversity within global cities. Furthermore, as with Picasso's paintings, urban dance culture can likewise be viewed as another artistic mode of representation or expressive awareness of place belonging, and as an artistic expression of the unique space-time of place. In this way, different art forms can enrich new place-making design processes and tools in architecture education. Okay. Finally, within the context of education, the three child pathologies point to the need for proper articulation between physical, social, and mental experience, which is required for a healthy life. When social relations do not develop, the wild child has basic pathologies of linguistic and other necessary intersubjective communication systems. When physical experience is eliminated by living within a virtual screen, virtual children forget sexual and social relations. Finally, when mental freedom does not exist and harassment and aggressive activities reign in educational, political, and social institutions, the concentration camp child cannot think and can even become suicidal. Moreover, these three pathologies reactivate each other in a dangerous process of human degeneration. The diagram is an articulation of education, architecture, and socio-historical interaction as a fundamental hermeneutic human structure, and it also shows the related pathological dysfunctions. We thus have a laboratory mixing the three structures, that is education, architecture, and social cultures, with their hermeneutic articulation through the three figurative axes of architecture, the prefigurative, which is design, the configurative, which is construction, and the refigurative, which is the use of space. These three axes and the three triangles formalize human memories within human life. And to wrap up, and to conclude, we argue that the formalization of architecture should happen from within and should involve social experience and interaction, since architecture is a language that we are living inside of.
Now the third communication, reimagining human nature coexistence and integrative approach to architectural design with the biomimicry, generative modeling, and AI. Okay. You are the two there.
Sorry?
What the two there? Carina Oliveira and Mauro, of course.
In fact, thank you very much for being here and to give me the opportunity to present this article, paper, research. And in fact, we are more than two. We had the support also of Leonor Domingos, that is here and will also present. And Filipa, Osório, that is not here, but is part of the same research institute, ISTAR and ISCTE in Lisbon, where I'm doing my research. I'm trying to find my glasses. I will not read things because I had no time to prepare it. So maybe it will work better because, well, I'll be faster, probably. So basically it's about me, Leonor, and Filipa, but also Carina Oliveira, that is from the University of Coimbra, and is, well, we are all architects except her, that is from psychology. And Mário Manaia, it's not from ISCTE, his research is based on Catalonia. It's Portuguese, but it's the research he did is from Catalonia, and it's related with the energies of the project. So what we are proposing here is, you know, the hobbits, the houses that hobbits from the movies. And basically what we are proposing here is something similar to that, but for real, which means that when you open the door, you know that those houses, they exist, they're in New Zealand, but in fact, when you open the door, you get inside of a studio that is in Hollywood, not there anymore because the spaces are very, very small inside. So the idea is to have spaces that are underground or undercovered or some semi-undercovered, and at the same time having huge spaces inside. So the trick is being inspired by methods like Gaudi to do it. What are the advantages? According to our first simulations, the simulations that we did, the first simulations that we did, we have up to 80% of energy savings with this methodology, because we have inertia, we have land inertia, soil inertia. So basically you can build this kind of structures between the North Pole and the Sahara. And you will have advantages in both situations and maybe also in Mars. So the idea is not to try to make it look like regular houses, is making it work as something that is underground and can resist a lot of heavy weights, all under compression, only compression, or mainly about being compressed. Materials in general, they can handle a lot of compression, and if you have the right shape in the right place, you can have tons of soil at the top of this with a very thin layer of structure that can be mostly about something that is good being compressed like stone, like concrete, but instead of big amounts of concrete, you have like a thin layer, like a shell. And that is the kind of study that we showed there. That is, how can we have, first we calculate the shape, and then we start to simplify, thinking about how to be produced, how to use, for example, CNCs to cut big triangles and to put it on place, of metal, of wood, of other materials. And then making like a mold that will be there forever, and also at the same time have precise geometries that can be very useful to divide the interior of the places, etc. So this is it. So we have these kind of images that, of course, the idea is to have at the same time a good connection with the exterior in the North Hemisphere, where we are now. Of course, we will point all the windows to south. And if you realize, if you don't pay too much attention, it's like being in a regular house, because you will have a lot of light. The only problem here is the ego of the architects that will be buried. So you will not have shapes outside, excepting the windows, these kind of windows that are catenary shaped like. You will not have nothing proving that you're there. So even the visual footprint, it's reduced to a minimum, the minimum that we can put there. And so the idea is basically this. Here it looks like Gothic, but in fact the structure is calculated to have a catenary there and to resist forces. So at the same time, we have also an approach that is biophilic, which means that we use a lot of green, because psychologically it's proven that since the 80s that everything is better when you have plants around. So this is it. Basically, the idea is that it's to create a good connection between the built and the born, between nature. Nature, it's a very extent extensive definition, but basically about what we can have, like the biome, local biomes, and the built things that we build. And so basically we are mixing ideas, calculus from a computer. Well, in this case, it's Caramba, and these images are from the PhD thesis of Filipa Osório, where she's calculating with Caramba some origamic structures to see how they behave. And then we have artificial intelligence to simulate some ways of how to construct those shapes and how to make them housing with that. Of course, we did some studies of energy, and the first studies, now we have several studies around the globe, but the first study and the one that was ready to present here in this conference was about Mediterranean situations. In this case, it was Madrid. That was the place that was selected because it snows, and at the same time, during the winter it snows, and during the summer, sometimes we have 40 degrees, and it's very dry as well. So we did it there, and the basic results were amazing. And if we start to project some active systems to shadowing the windows, it will work even better. Also from Madrid, we are following a research that is done there, because biophilic it's okay, but even more and more efficient than biophilic structures are structures with algae. So there are researchers in Madrid, research that is conducted by Rosa Cervera, and they are doing now, this is already a photo. This is a simulation, but that is already a photo. When I did this simulation, I sent it to ask permission to present this, and Rosa Cervera showed me the prototype that is already almost ready. So basically, this is about tubes with water and microalgae inside that can absorb even 10 times more CO2 than regular plants, plants from terrain plants, let's say. So these algae are very efficient, and at the same time that can provide us biopolymers to substitute oil products. So this is something that is in parallel with our research, but we have to pay attention also to this kind of research, because this is not a passive system, but it can be part of the exposed areas with light that we have in our caves, let's say. And these are some results that of the workshop that we did yesterday. So basically, our idea is always to follow the structures that are basically under compression. If we do this, then if we cover this with a material like stone, like granite can resist. Imagine that you have a cube of granite here. You can put 11 kilometers of granite on top of that first stone before you have any kind of explosion of the one that is above all the others. So with compression, working with compression, we can have a lot of good results. And imagining that we are 3D printing this kind of shapes, we also can think that we can use to provide some stress resistance We can also imagine fibers, vegetable plants, some green fibers that can be used like hemp or bamboo fibers to reinforce these new concrete kind of cement. And basically this is it. And this is also a simulation, but it's based on the photos of a building that was made by a group called the Barro in Portugal. But that one is from Argentina, in fact, but it's from a Portuguese group that used to do these kind of domes with the earth, compressed earth, bricks made with compressed earth. And the only thing I did here was with artificial intelligence to put it in, put myself inside and to paint it in white colors to see how could be, how lighter it could be. And I think this is it. Thank you for your attention.
So, hello, my name is Kaiko Kivi. So, reimagining digitalized space. Integrating meaning and technology in building systems. I'm a PhD student and a junior researcher at the Estonian Academy of Arts. I have a great honor to be here. Thank you for accepting my abstract. My supervisor is Dr. Rene Buse, who is a senior researcher at the Academy and also an eager developer of configurable and circular buildings related digital solutions. My thesis aims to develop a framework for scalable modular design, but here I try to open the hypothesis for a case or a sort of a more abstract case. The title of my presentation sounds perhaps overly ambitious, like it's aiming to disrupt everything in architecture, engineering, and construction. But the aim of rethinking is meant to kind of refresh and moderate some of the strongholds to reach a kind of a common sense. In the beginning of the past century, Le Corbusier wrote, a new epoch has begun, and we must create a mass production spirit, stating the need to look at the industrialization of the art of construction as a new normal, something that we cannot evade as architects. Today, a century later, we are facing a similar reality and often note that the productivity of construction and its sustainability goals are still low. So something we ask today all the time is what is the purpose of more construction? In the Anthropocenic climate crisis, we need to think, do we actually need more buildings? So most of us have probably heard that the construction sector is responsible for about a third or more of energy consumption and greenhouse gas emissions. But looking at the breakdown of this, we see that the majority of this is related to the operation of existing buildings. And only 20% of it is actually new construction, and 9% is infrastructure. So in order to kind of replace the operational carbon of the buildings existing, it would take us probably decades and involve a lot of new construction. If we want to speed that up, it's even more new construction. So this realization is not new. We need to be more efficient, has been historically the aim of industrialization in construction for a century. But I try to pose the problem in a different light. So if building is the object in short term, then construction efficiency is the main goal. But building for the sake of more buildings in locations where high financial returns justify the cost may not resolve the actual needs to reduce the ecological footprint of existing buildings. So this is the business of housing development in market economy, or mass production of housing in top-down political system of collaborative housing. It's about the efficiency. To look for a sustainable solution, we need to ask for the sustainable goals of the effort we intend to make. So we may retreat for a moment from the economic aspect and try to understand the underlying need, which is spatial. People need sustainable spaces to dwell, work, and live. And we need to solve that problem at scale, big scale. So here is an image of prefabricated housing. Industrialization has been one of the methods for improving efficiency of building sector. Mass-produced housing is about efficiency and minimum requirements, but not so much about the quality of living environments. So especially variation and adapting to users' preference or location is seen as a counterforce of efficiency in mass production. The picture here is of constructing social housing blocks in Tallinn, Estonia from 1975. So you see it's all dull and the same kind of buildings and exact same apartments in them. The buildings are constructed by replication of standardized designs, which is a matter of efficiency. So industrialized housing in general has many benefits, but also challenges. I'm not going to go into this at the moment, but my work aims at the design limitations in the challenges. So how to sort of open the design up from a very typical replication. To bring an example that is often popular to show is here's a housing estate in Iztapalooka at the outskirts of Mexico City. One can argue whether this living environment is a good investment for the low-income inhabitants whom it's built for, because they are also placed into a high mortgage, and when the value declines, they actually are in a worse situation when they want to leave this environment. And then there is a kind of interesting example from here, Portugal, which is a more sort of friendlier. And here the attention has been put to the inhabitants' long-term interest of providing a valuable living space. The housing is designed to take future households as partners and provide choice model to define the spatial layout of the home, and that may even be further modified over time. Here, the diversity of families and communities' social needs are appreciated, and a customizable set of houses is provided. Architect Alvar Sisa utilizes kind of formal pattern language here, but I would also note that the architect continues the supervision of the site for decades. So in 2005, Jose Duarte, who's just presented here, developed a kind of formalized digital syntax for creating additional layouts in this same system. But since studying that some years ago, I've been wondering whether a formalized system like this can be applied anywhere without architectural supervision. And one may ask if it did incorporate all the aspects of living quality, and should we sort of let it open? So I ask, perhaps there is nevertheless a need for a consultant to supervise the progress of choice and the overall configuration of the space that emerges in the process. Or what if the space itself is an expression of living quality, as proposed by Bill Hillier and Julian Hansen in the social logic of space? The elusive space between material form and buildings, of buildings and structure, is kind of omitted when we optimize for construction. Therefore, if it is the very essence of architecture and the purpose for the construction of residential housing, how can it be static and standardized? Functional space should be the entity that ties together the arrangement of building elements that are assembled through the construction. As stated by Bill Hillier, in the space is the machine, space is the essence of architecture that differentiates it from mere construction and decoration of buildings. Arrangement of meaning in space and configuration of space is what it means to do architecture. According to the concept space is the machine, architecture is the design and arrangement of space. This perspective views space as an active and generative rather than just passive container. It is the manipulation of organization of space that gives architecture its function and meaning. Going back to Malagira grammars, so design variation in space is one of the essential matters for successful development of value in living environment. What if the grammar of space is not meant to be reused anywhere, but we should develop grammars based on context, but through a prism of building system for efficiency? Because repeatability in building is important for efficiency in construction, but perhaps it does not need to apply to how we resolve spatial configuration. Considering that efficiency matter, I look at the building design in general and how it goes through a sequence of stages. It is often argued that early stage choices matter for design of energy and cost efficiency of buildings. But without relevant feedback, it is difficult to take this into consideration in the concept design phase. The starting requirement of efficiency in any aspect is the perspective of feedback, how far we see, how far we can imagine and foresee the details. And it applies to application of building information modeling, adaptability for prefabrication, building performance assessment, energy efficiency, life cycle analysis, carbon evaluation, carbon emissions. Everything depends on details in the downstream. So how do you consider the matters of efficiency in the earliest design phase where the spatial arrangement is actually decided? Feedback is typically only available step by step, which makes it difficult to develop early designs in unfamiliar topologies and innovative building technologies, as we have seen here also some. When specific information is crucial for decision making. Because each step and choice has unknown consequences down the path, we use model simulation to peek further. But without design process integration, it is hard to foresee further than one step or one discipline. We can simulate one discipline of engineering or heating, for example. So the proposal here is that we need to develop design automation in order to iterate into the process. And to bring that as early as possible, we need to integrate spatial topologies with tools that automate the detailing. And then we can do rapid iterations in different sites and proposed spatial arrangements or changes in spatial arrangements. And the key is the iteration, that we can go through more and more design choices with the potential of developing more sustainable building systems while still not falling into the trap of repeating the exact same spatial solutions. So as part of my research, I started to work with modular companies, and I identified a number of challenges that might be addressed by digital means. In conclusion or combination of those, I found that the most difficult problem is integrating different digital models and systems in such a way that it would be possible to iterate through automation and choices, which kind of defeats the efficiency of all building systems. If you cannot do that, then you fall into the we have this solution, you can have it or not. So I need to speed up, I think. Sorry, 4 minutes. Okay. So in configuration of buildings, prefabricated buildings, there have been identified 5 layers of choice you may have. The highest level is spatial layouts. And for the house manufacturer or prefabricator of buildings, this is kind of something that they want to avoid, but at the same time, market comes and asks. Every client has their own site, their own economic or business plan. They want different sizes, different layouts, and that's what the prefabricators have to face in the market, making rapid proposals in order to get contracts. As part of my exploration, I have been collecting and following active participants in technologies and computational architectural design, trying to figure out what could be the solution. And as I said, integration between different tools seems to be the challenge, and trying to understand how to integrate between spatial needs and building products is where I found Topologic or Topologic by Wasim Chabi, who's going to have a keynote tomorrow. So Topologic introduces a comprehensive list of classes that enable modeling non-manifold topologies. Considering the architectural space beyond single shell structures is non-manifold, there needs to be a formal notation to manage its form, to enable variability and parametric design for space. Topologic also enables non-regular operations to compute with spatial topologies. Its context, in the context of this study, it has been used to combine and imprint spatial organization into modular structures. A set of manifold and non-manifold topological operations allows the spatial computation otherwise impossible or infeasibly complicated in conventional BIM or CAD tools. So what this enables a quick sort of experiment or case. So here is a potential site with structural topology imprinted and then structured as modules. So the second layer of this is actual like spatial layouts of the apartments. And in combination of these two topologies, it is possible to find the sort of building solution and at the same time configure the possible spatial variations. It goes on like possible 2 floors. And now, based on this topological knowledge, it's possible to extrapolate the building information model that gives us the details that we need. Also equally, the potential manufacturing models can be tied to this topology. And further than this spatial configuration, of course, all the other sort of decorative or finishing configurations can be offered to the use or the architect or whoever is the kind of input provider. So as a discussion, it's a question of how it fits the problem. If the space is the object, we can imagine workflows for improvement of building development through spatial configuration and technological building systems independently by integrating the systems through topologies. Yep, so this tries to stress the need for a formal and lightweight notation, as Wasim Chabi also has been pointing out, and then we can sort of automate the design details in order to get the necessary feedback to both optimize the building process, but also consider the spatial variability that we need as architectural input. Thank you.
It's from this last presentation, which I tend to find very interesting because it gets to this kind of like how can we produce variability if we are doing we still in the industrial paradigm in terms of mass producing stuff. I just going to probably but I think it's worth to note it. If you know the work of Gilles Retsin. So where it kind of like it flips the way that it's rather than be the formal or the topology of spaces, it's rather the sets of operations and procedures of assembling material that creates variability. So I think that could also be because it is another set of rules that could also be very interesting to explore and to unveil.
Yes, I consider that kind of the output, the building system, which is like equally our system that Charles Ritson is producing, but with an input of various architects.
I can like in the not this presentation, but the Orbit presentation. To the Orbit presentation. Two questions. Are you considering daylight levels? I know that you talk about the windows that are facing south, but it seems that the structures that's resulting from the workshop from yesterday are very deep land structures. So like side lighting can do as much. So are you like considering like like lit a space through just using side lighting strategies can do as much? Is a little bit limited. So like, are you considering introducing light? And then a second question about that is, I know that probably it's energy efficient, but are you also, I know that you're optimizing to reduce the amount of material, but there's a lot of layers when we do a green roof that has come to that. So green roofs actually when we look at carbon, embedded carbon, actually are quite heavy.
There's a difference between these kind of structures and green roofs. Green roofs is something that you put in a concrete layer in a building that has a surface at the top. Here we are not talking about that kind of structures. We are talking about the kind of structures that the shape itself resists under compression to the weight that it's at the top. So the difference is between, okay, that layer that stabilizes a little bit the temperature of your building when it's a flat roof, that layer with 10 centimeters of earth that weighs a lot, 200 kilos maybe per square meter. And the other one is kind of shape, Gaudi's like stereofunicular systems shape that resists to tons. We were calculating, for example, for Madrid, we were calculating about at minimum 2 meters deep of soil. So it corresponds to approximately between, it depends if it's wet or not, but it corresponds to something between 3, I don't want to lie, but it's between 3 and 8 tons per square meter. The proof that this works is that we have millenary constructions around the world that are underground. One of them was discovered recently in Turkey. Sorry. Yeah. So there were like not only housing, but also squares underground, and with capacity. That city had a capacity for 20-something thousand people living underground. about the light. In the North Hemisphere, we have to point all the windows south. If we have a mountain, it's perfect. If we don't have it, also we have to for example, in China, I studied some examples in China where they excavate a claustrum and then they put the houses around the claustrum. And it worked because they are living there for 2,000 years now, so it might work. It might work. And also, I also did a study about conducting lighting, light like we have in the cruise port here. That is about conducting light with several systems, like just tubes, mirrored tubes to conduct the light to the interior and have a landscape with natural light inside. Definitely, you can do it this way, or you can just somehow having a kind of small mountains. But here we don't need to create them. We can just put we can build near one. But in the case of, for example, Netherlands, they will be amazed with this kind of solutions. Definitely.
Just a final comment. It could be very interesting because moving soil also could cause environmental hazards. Moving a lot of soil, it could be that the soil that you're putting on top, it could be it could be a net zero, a zero-sum game. That the soil that you're putting on top of the roof is exactly the soil that you need to dig up to make the foundations of those things, in order to make to justify that you're moving the least amount of material, not only the optimization of those arches in those domes, in those vaults, but also the type of soil that you put on top.
In the in the most part of the scenarios that we are studying, it's quite messy at the beginning because you have to take the land, the substrate, the living part with all the mycelium and the trees and everything, and then we have to put it again. Also, we can consider these kind of situations that to be applied in places that are already in decline in terms of biological life, of biome, of diversity, etc. So the idea is to keep it to keep the connection in the long term, of course, because when we build, we think long term. So the idea is, okay, at the beginning it can be quite messy, but in the long term we will have the communication between biomes there, and probably everything is restored in several years. Mycelium and trees and everything will be there, worms as well, all the life. That is the intention of this strategy, definitely. And also to impact visually as less as possible.
Okay, for Mauro, we'll continue the discussion. Well, for structural reasons, I think when you worry the construction, it's a very good solution. I think the tomb Agamemnon is one of the first examples in the Bronze era of well, I think it's the invention of press dressing. Very, very fine. Well, but for climate, is it a climate solution? It's difficult to say because, well, we construct over the floor Earth for many millennia, and we perfection those solutions, or we perfection the little solutions with that in mind. So I participate in when Portugal was beginning to think of regulation for the thermal in the 80s. In the 80s, there was the regulation of climate. Yes, and one solution that was being studied was precisely the buried one, the Teletubby house. Yes, and well, it was very difficult to achieve good solutions without a lot of research. The lightning problem already said it's, well, all the solutions. And another one is ventilation, for example. Another very difficult because, well, we have houses that have millennia of evolution. And now new radical solutions will have problems that, well, need the research and research and research and research. But I would like to address all the others. We try to, in organizing the symposium, to make sessions with some topicality and grouping topics. Well, this session, this panel was dedicated to some well, brother, well, we are here, many of us are technicians that treat with we deal with the technicalities of formal methods. And well, this session was prepared to discuss some broader questions and other points of views. So it's many positions have been produced here. I think if we want to discuss those questions, for example, in the intervention of Margaret, I have strong disagreements of ideological disagreements, not political, ideological as global points of views. For example, Husserl and Ricoeur are my ideological enemies. Kant, no, not Kant, but the Kant aesthetic of Kant is miserable for is in the third critique. I just say third because it's the least known critique of Kant. The other two, I have a strong. I don't agree with everything, but I think there are marks of humanity, but the third critique on aesthetics, it's miserable. And well, but you referred also Piaget, and although you, what said, I don't like, but you have demonstrated some particularities. For example, the Scheid experiments, the experiment with children and space. I think it's marvelous and very interesting. And so we, in the discussion, the light appear. So well, to discuss all those things.
Okay, well, first of all, ooh, can you hear me? Okay. Yeah. So first of all, I'm not an expert in philosophy, and the main author of this presentation was JOSEP MUNTAÑOLA. But in general, I think the point of it was to create, to bring in a new perspective into the conversation. And the Paul Ricoeur and the hermeneutics and Bakhtin it's about, I guess, introducing a kind of, the dialogical way of thinking and the relational way of thinking that incorporates social interaction into the whole brain-machine dynamic. And sort of to underline the importance of this when, I don't know, when programming, when developing the new technologies, that when thinking about form, like, I guess to bear in mind that whole dimension, which is often left out of the conversation. And so I think it's just a different perspective on the topic.
Okay, okay, okay. Anyone?
Just answer a little bit, talking a little bit about, well, you put a lot of questions and I don't know where to start, but maybe the first one is that, okay, we are used to this kind of buildings that we do, and we did it for millennia like the others. Underground construction is something that is there from millennia as well. And it works quite well. And the advantage of this, among a lot of them, another are about stability, thermal stability, construction stability, etc. Also, we cannot think like in the developed world that, okay, what we need to do is to preserve and try to reproduce a little bit more because we are being extinguished here. So basically we don't need to build more housing. We don't need housing here but developing countries need housing and they need another solution or something another alternative solution to the way we are building here and we built till today. Ventilation is something that termites do it quite well. And also in Istanbul, the city that they found, they use the same methods. By convection, they can ventilate quite well. Well, at least there were 20,000 people or more living there, so they were breathing somehow and without forced systems. I don't know if I missed something.
We should say that in Portugal, we know that 1.5 meter underground, we have a temperature of 14, 15 degrees Celsius all the year. So it's very, well, yeah, so the climate necessity to get the temperature for ourselves, the comfort, it's very low. So the solution to bury the house is, well, something that we can think fairly